In this video, we're going to be talking about how to convert an equation from rectangular coordinate points to polar coordinate points. And the first equation we've been given is this equation here, x squared plus y squared minus 2y equals 0. We're also going to be doing a second example. So our conversion formulas for converting between rectangular and polar coordinate space are these three equations here. So what we want to do, first of all, is recognize that whenever we have x squared plus y squared, one of our conversion formulas exactly is x squared plus y squared is equal to r squared. So if you ever see that, you want to make sure to convert it right away to r squared because that's a big win. So we'll get r squared minus 2y is equal to 0. Then, because we have y here, and we know that y is equal to r sine of theta, we want to make that substitution. So we'll get r squared minus 2 times r sine theta is equal to 0. Now r is a real number, so we can go ahead and divide both sides by r. Dividing r squared by r just leaves us with r. Dividing the r out of this term, we are left with minus 2 sine of theta is equal to 0. And then whenever possible, we always want to solve these equations for r in the same way that equations in rectangular coordinate points are usually given in terms of y equals and then something in terms of x. Polar equations are usually given in terms of r equals and then something in terms of theta. So if we can solve for r, we want to do that. In this case, we can just add 2 sine theta to both sides, and the result is r equals 2 sine theta. So that's a perfect polar equation right there. This will be the answer. This equation represents exactly the same curve as x squared plus y squared minus 2y equals 0. Let's look at a second example here. This one is y is equal to x root 3. So we want to use our conversion formulas and plug in for both y and x. So y is going to give us r sine theta. X is going to give us r cosine theta. And we're multiplying this whole thing by root 3. Now if we divide both sides by r cosine theta, then we get r sine theta divided by r cosine theta is equal to root 3. That's going to allow us to cancel r from the numerator and the denominator, and we're just left with sine theta over cosine theta is equal to root 3. Now because sine over cosine is equal to tangent, we could convert this to tangent theta equals root 3. But really what we want to do here is try to solve this equation for theta. Notice that we've eliminated r completely, so the equation is only in terms of theta. So if we can solve it for theta, that would be ideal. So what we're really saying here is that when we take sine of the angle theta and we divide it by cosine of the angle theta, the result is square root 3. So what we want to do is go to the unit circle and find the angle theta that's going to give us this result. Remember that all of the coordinate points along the unit circle are given in terms of cosine, sine. In other words, the x value in the coordinate point represents cosine, the y value in the coordinate point represents sine. So when we see this, what we're really saying is if we take the y value and divide it by the x value, the result should be root 3. And if that's true, then wherever that occurred, that's the angle that we want for theta. If we know our unit circle, we know that the only place that's going to occur is this point right here. The sine value, the y value, is root 3 over 2, and the cosine value, or the x value, is 1/2. So if we take sine divided by cosine, remember that that's just like y divided by x. If we do y divided by x here, we get root 3 over 2 divided by 1/2. Well, that's the same thing as root 3 over 2 multiplied by, here we take the reciprocal of the denominator and we get 2 over 1. Then we cancel 2 from the numerator and the denominator, and the result is root 3 over 1, or just root 3, and that is the value that we want. So we know that this coordinate point satisfies the equation. The angle there is pi over 3. So because pi over 3 satisfies that equation, this equation here becomes theta equals pi over 3. In the same way that this curve and this curve are exactly the same, y equals x times square root 3 is the exact same curve as theta equals pi over 3. Could you use some extra help with math? Click the button to head over to calculusexpert.com. It's where I've collected and organized all of my best resources, including exclusive videos, notes, quizzes, and even formula sheets. It's the perfect resource whether you're struggling, or if you want to take your learning further, or even if you just want to save yourself some time studying. So check it out, because I know it'll help.